Professor, you are muted. There's no audio.
Okay, class. Bismillahirrahmanirrahim. Shukranullah, can meet again. I think my line could be interrupted. No idea why. You can hear my voice, but unfortunately, you can't receive the screen, isn't it? Now, can you have the screen now?
Yes, doctor.
Yes.
Okay.
Yes,
Thank you for
doctor.
being with me, and thank you for again joining me back. Let's try make full use of this time just to make a revision that you can you can have a better understand on solving the problem later on. Yeah, not only for the test and exam, for the sake of knowledge, and you can be a good engineer to be ahead, inshallah, in your line of as engineer later on. Okay, now let's start now by this one. I think we could be completed this one, isn't it? I've been talking about this one just now. Saying about the completion of the graph is not completed. The graph is not completed by mean of data. So the T-min will be provided, isn't it? So let us now try to solve this one. Have you have this one? No. I change my screen now to my working. You have my working here.
Yes, doctor.
Okay. Could you please sign up as the purpose of attendance? This is not recorded your attendance. This is for my own initiative. Recording the attendance. Okay, now come back to this one. This one is the calculation from what we have earlier. This one is the calculation from the graph, as I mentioned earlier. The T-mean and the red shaded area is given by this one. You have 70 by 14 and multiplied by the omega to convert the second to become radian. This one is the first portion of the graph given by the machine, and the other one be of course the second one, and that one the third one. This one minus by t multiplied by 5 omega, which is the bottom part of the zero here. This one, the small portion here. Okay. And as you count this one, you'll be getting as such, you will be getting 980. This one will be of course equal to this one is, you can cancel this one, cancel, become 200 omega plus this one. Of course, we have by 5 is 1000 omega. This one is minus by this one is t by 5 omega. If you work this out, you have t here is equal to I calculate this one, you will have 44 44 second, 44 Newton, 44 Newton meter. Okay, so that 44 Newton is basically, of course, they've got negative here because below the area, below the zero. So this one is negative 44. Okay. So I'm answering the second part, magnitude of torque given. The next one is the mass moment of inertia of I, to define I now. Okay, as I mentioned earlier, many times, you start with from to find I from beta E is equal to I alpha omega mean power of 2, can also be get by E max minus by E mean. And this I, you rearrange the equation becoming beta E divided by alpha omega mean power of 2, or perhaps the E max minus by the E mean divided by alpha omega mean power of 2. Okay, you work out this one. No mark given for the equation. Okay, no mark given for the equation. But if you found there, sometimes your calculate your sometimes for example, sometimes most of the students forget about this power of 2 or power of 2. This one they put alpha omega mean. Of course, the equation is not correct. So this one will be minus because you need to know how the derivation of the equation. back to this one. So you need to look for the Emax and Emin, and you know well that Emax Emin can be only defined by this one. That can only be defined by doing energy analysis, as we discussed earlier. And alpha, this one can be calculated from the very beginning. Alpha equal to, you have the N max, or perhaps you can also use omega. Yeah? You have N max, this one minus by N min divided by N min, isn't it? So of course you need to know what be the N min here. N min here is equal to N max plus N min divided by 2. So this one will allow you to have 505 as given, plus is 495, 495. You add up together divided by 2. It basically give you 500 RPM. So you will have here 505 minus by 495 divided by 500. So you work out this one. So that will bring you 0.02. Or it can also be written as 2%. Okay, 2%. Okay, now I'm going to find beta E. To find beta E, this one from energy analysis. So for energy analysis, we have to go back to our graph. Go back to our graph here. Look at the graph. The graph. So what is the energy analysis? Is the energy analysis basically based on the graph, and the graph must be in one cycle. This one we already noted. This one is one cycle, one cycle, one cycle. So how is it? Check the intersection point of the line. What are the line? The line coming from the machine, this one, and also intercept with the line of motor. So these two lines will give you intercept point, intersect point, intercept point, intercept point. So put it there as A. Name it as A, B, C, and D. Okay, and again you have a slanting here, slanting line. You need to know what be the small portion here. The small here, this one. You do not know what is the small portion here. So put it there as X. Put it there, small one as X. So use a magic triangle. Remember, similar triangle, magic triangle, or interpolation. If you are doing thermodynamic, called interpolation. So how is it? Start with X divided by 2. This one, yeah. X divided by 2. 4 minus 2. And is equal to, we have 200 minus by 70 divided by, you will have 200, isn't it? By 200. Small triangle divided by the big triangle, isn't it? So what you have next, you will have equal to, so if you calculate and that is correct, you have X equal to 1.3. So this small portion is equal to 1. Then you start calculating the area. So what are the area now? I'm going to, erase or clean up the area that we don't involve here. Not involves, so not involved. Okay. This is the area now. So the area, the new area will be this one, and this one. So that will be the new area. The energy we keep fluctuating below and above T mean. This is T mean, right? This is your T mean. And because we are talking about motor drive machine here, remember, you have to ensure that any area above T mean, I can change the another color to be red now, so easy to differentiate. So if I'm saying this one is a turning moment, is a turning moment that I'm coming from the motor drive machine, any area above T mean is negative or positive? This one.
Negative.
Negative. And the other portion will be positive. And you're aware that if even though you take this one wrongly, you'll be getting the same result, isn't it? But wrong concept, and of course, mark will be deducted from your working, typically for the energy analysis. Okay, come back to this one. So I'm going to calculate the whole thing here. The whole thing, this small portion here, and this one, let's say this one is A, B, C, and D. So let applying the conservation of energy, saying that energy conserved, applying this one, conservation of energy. So now let energy at A equal to U, at B equal to, if you go back to the graph. Yeah, this one again is a trapezium. So the trapezium is, this one is 2, this one is 4 minus by 1.3. So you'll be getting 3.7, 2.7. Then the height is 70. So that is the area. So you have half u plus, you have half, this one 2 plus, just now is 2.7, and multiply by omega by 70. You have the result here is u plus 164.5 omega. Then you go move on to C now. C is equal to, you have u plus 164.5 omega. You move to C. Where are you? C is here, isn't it? So this one, another trapezium. Another trapezium phi. This one is 1.3, is 6.3, isn't it? And then multiply by 200 minus by 70. So you work out here. So we have the result of minus by half. This one be 5 plus a small portion just now, plus another 5. This one is omega. This one is 200 minus by 70. So you work out this one, you be getting this one, the result of u plus 164.5. This, the whole lot will give you 734.5 omega. And you put in this number in calculator, you be getting the result of u minus by 570 omega. 570 omega. Move on to D now. Move on to D equal to, look at what D is. D will be this one, right? D is easy because we have the rectangles here. So it's 70 plus 44, then you multiply by 14 minus by 9. So you will have here u minus 570 omega. And you know that if my calculation is correct, you'll be getting 0 here because we are talking about energy. It's been conserved. This one is 5 plus by, you will have that one is 70 plus 44 multiplied by 5 omega. You'll be getting this one u plus 70 omega, this one plus 570 omega, and then u plus 0. And it is correct because energy is conserved now. Then it's correct. It's very easy to define whether your calculation is wrong or correct. Yeah. Then you start picking or selecting or choosing where will be the maximum energy fall. For example, this one, tick positive. Okay, this one positive. This one is negative, tick this one positive. Isn't it? So another one is also positive, plus 0, also positive. So your maximum will be at B. So this one will be the at maximum. I already mentioned in class, supposing we have all negative, so 0 here will be your maximum. Okay, then a part of that, you know that this one become your E minimum. If I see maximum, but I put minimum. Sorry, the synchronization is now at the moment not very good. This one is maximum. Then the other part will be E minimum. This one is E min. So what is the function of this one? What is the function of energies? What it is used is to what? To get E max and E. Remember that. The function of energy is to get, or the use of energy is to get E max and E min. So you know that beta E now is equal to E max minus by E min is also equal to U plus 164 plus 5 omega. So minus by, you have another one is U minus 570 omega. And you work out this one, you'll be getting, inshallah, the result that will give you is 734, sorry. Yes, 7, I put the calculator here, 734.5 omega. Omega. And of course, you need to change omega to become a real number. So you have beta E now is equal to 734. The omega is 2 pi times 500 divided by 60. So that will give you 1,000 something. It's about so huge. This one is so big. We have about 38,000 4 by 8.3 joules or Newton meter. Can also be in the form of Newton meter or Newton meter. Okay, class, any question?
Doctor,
Yes.
if we use the alternative method, will marks get deducted?
If you do what?
The alternative method to find the area upwards.
Okay, the magic work. Okay, now. Okay, I answer your question. Alternatively, you can check the beta E by calculating the top area, isn't it? The top area where you found that only one area, remember, overshooting above the mean. For example, here, come back to here, want to prove that I answer your question, yeah? This one, top half, this one, only this one. Okay, how is it? How is it? We can calculate the one by using beta A now is equal to what? Can you calculate for me that, class? What is that one? That is half the trapezium, isn't it? It is look like very much like the trapeziums. So how is it? Is 5, put it there, you have 5, this one 5, 5, 10, 1.3. Okay, 5, 5, 1.3. So we have 5 plus 1.3 plus another 5 multiplied by omega multiplied by the height is 200 minus by 70. You have 200 this one minus by 70. So you work out this one, you'll be getting inshallah the same result as what you calculated earlier. 3.4.5 omega. Okay, so question. If you calculate this one, do I get the full mark? Do I get full mark? The question is yes. The equation is yes. It's yes. Okay, you'll be getting the full mark, inshallah. Okay. But as I mentioned earlier, if you do this one, at least you have to inform me, because the other class, I don't know whether the other class use this one as a part of the solution or not. Okay, you do this one and you you text to me as mentioning about your name and also your metric number, so I can check whether it's been marked correctly or not. I'm not underestimate the lecturer. I'm just play safe to ensure that whatever you've done in class, and correctly, you'll be getting full mark on that. So, but if the question asking about what, about show or state, the point of maximum and minimum, is very difficult for you to state that, isn't it? Because you do not know where will the maximum and minimum fall. Am I correct? Correct? You do not know whether A, B, or C. By calculating this one, you know that it will fall at E will be minimum and B will be maximum. But by doing this one, you do not know where will the maximum and minimum fall. So this one, you will be deducted by a couple of marks because you do not show where will be the maximum and minimum. So in other words, you have to read the question very careful. Education doesn't bother about asking or pointing where the maximum and minimum point. You can use this equation. But when they're talking about maximum minimum point, you need to do the normal procedure, and you take this one as the equation to counter check your results. Am I answering your question? Hello?
Yes, doctor.
Okay, now I move on. Calculating I now. Okay, calculating I. So therefore, my I now is equal to, already calculated I here as this one, we give the results here, this one I. E max, E min, alpha, omega mean square. Put it here, beta E. You put beta E divided by this one, alpha, omega mean power of 2 is equal to, this one we calculated as 734.5 omega, if I'm not mistaken, am I correct? Yes, 734.5 omega. Then you multiply by, divided by, this one is 0.7 Is that 0.2 or 0.02? Just 0.02. Then this one is the omega square. Of course, this one is mean, this also mean. You cancel this one, you cancel this one, and that will give you 734.5 divided by 2.02 multiplied by 2 pi by 500 divided by 60. So that will give you, if you do that one, so that will give you, I have numbers here. You will have, it's not so huge. This one is, you have not so big. You have 701.4 kilogram meter square. Okay. So next one, to define what? To define, the next one is to define, okay, yeah. To define the radius of the flywheel, it provide you the I, sorry, they provide you what will be the density, and also the radius given by R to 4 is, R to T is 4, ratio. Yeah? So from half M, or perhaps I put it there, from I is equal to half mr square. So because they do not provide you, the what they call it, the figure, but they provide the radius just S, R, and T is equal to 4. It simply means that from this one, you can assume that this one is belong to the solid disk. Okay, this one is belong to the solid disk. Okay, now you have R here, you have M. So you put the M here is equal to, remember, rho V. And this one you open up rho, this one the velocity at the volume will be A multiplied by the thickness. And again, you open up the area will be rho, this one will be pi r squared by T. And then you start simplify the R. This one, yeah, is 4T, for example, yeah, this one is R, you have this one is 4T power of 2 by T. Then you put it here is equal to half the M be rho pi. This one is 4T cubed, isn't it? Then you multiply by this R will be another 4T square. So that will give you equal to half rho. This one is pi. This one is 16. Sorry. I think I do wrong. This is not correct. This one is not correct. This one is not correct. This one is supposed to be 16. This one is 4 power of 2. 6 is correct. Huh? T cube is correct. Then you have the 16. This one another 16. 16 is 256. This one is T power of 5. So this one is 701. What do we have the earlier part is 701.4. So your T now is equal to, you can, if you solve this one, T will be 701.4 multiplied by 2 divided by, isn't it? This one is 8500. This one pi multiplied by 256. This one will be 1 by 5. Okay, so that will give you the result of 0.73 meter. So that will complete the results. If the question asks you about radius, for example, is equal to 4T, so you will have the result of 4 multiplied by 0.43. You have this one in meter. Any question? So that is the completion of the test set number 1. Any question?
Doctor,
Yes.
I want to ask about the alpha.
About the alpha, yes, please.
If the question given the fluctuation of speed plus minus 2, so the alpha will be 0.02 or 0.04?
Okay, thank you. Alpha is equal to plus minus 0.02, isn't it? This is your question, right? So what will be the exact answer of alpha. Am I correct? Is that your question?
Yes, Doctor.
Okay. What is alpha? Alpha stands for what? Is n max minus by n min, remember? Divided by n min. So you do this one. This one is n. Put it there. I put it there n2, yeah? N2 minus by n1. This one is n. This one n2. This one is n1. This one is n. So this alpha will be here. Am I correct? Isn't it? So this alpha will be here. So you have the alpha plus here. This one will be 0.02. This one will be 0.02. Am I correct? Plus and minus. Yes or no? Yes or no?
Yes, Doctor.
So your alpha is basically what? Your alpha is basically what?
0.04.
Your alpha is basically 0.04, isn't it? But this alpha is ranging for this one. Then you have to look for what is the n mean here. Go back to here. N mean, n max, for example, yeah, or n2, for example. Put it there. N2 is easy. N2. You have a n2 is equal to the n plus alpha divided by 2. Am I correct? This one is your n. Yes or no?
Yes,
If you
Doctor.
want to put n mean equal to n minus by alpha 2. So now tell me what will be your alpha now? In the calculation, this one beta E is equal to I alpha omega mean square. So what will be the alpha now? Yes, alpha is 0.02. Alpha is 0.02 because we have divided this one by 2. Sometimes they do not put this one plus minus. They put it what? They put it as alpha equal to 10%, for example. So your alpha is basically 10 divided by 100. Or sometimes they put it as alpha equal to what? Look at here. How this alpha given here. Alpha is equal to n2 minus by n1 divided by n. If you bring this one, you have alpha n equal to n2 minus by n1, isn't it? What does it mean here? It means that what? It means that this one n2 minus 1 is alpha n. What does it mean here? It means that the difference between maximum and minimum multiply this one. So you have to read the question very, very careful. But don't worry, in our syllabus, yeah, this one will not part of your question. This one is typically in books. If you book, most of the book will be in this term. Okay, any other question? Any other question? Okay, now we still have couple of minutes. I would like to share with you another one, which is the other assignment on the other topic. On the other. This one is 19. Pick up another one. This one 19 semester 1. This one, yeah. Do you have with you the screen, the new screen with you?
Yes, sir.
Yes, sir.
Okay, this is new patient. I'm going to close the old one. This one because so many files here. I'm going to open up a new file for my working purposes. 1 minute, yeah. I'm going to open up my file here so that I can work out here. And I get check here this one. Okay. Okay, now. First question. This one is December last year, 15 December 2019. 1920 semester 1. This one also during the PKP or MCO. Okay, what you have here again, we have 8 impeller. This one is 8 impeller. A up to F, A up to G, H is the and this is the actual thing. This one is I show you. This is one is the actual thing. the actual component. This one is the actual component, and we bring to you in class in this form. Okay, you have the 8 impeller, mass 2 kg each, and fixed onto a uniform shaft. The uniform shaft will be this one inside here. This is presented here. And this one for the vertical multi-stages pump, which is rotating with a speed of 1,500 constantly, as shown. The pump is supported by 2 bearings. This one, yeah, 2 bearing, X and Y. And the system is, look at it, initially totally balanced. What does this mean here? Initially totally balanced. What does this mean? What does it mean? Initially totally balanced is simply mean that every impeller is rotating about what? Center of rotation, isn't it? So, or perhaps the eccentricity of every impeller is 0. Or the center mass of the impeller is found at the center of rotation. So 3 different definition, but it's exactly mentioning about the initially totally balanced. Then a few modification been done on the impeller. One be the impeller H, D, and B, where you have to remove and you have to add. Okay, with certain magnitude, radius, and also this one is the direction. So one, the dynamic force of each bearing X and Y. This one is exactly as what we done earlier. I'm not going to do this one. So look at here, the second part. Look at the second part. The counter mass to be positioned, the counter mass, this one here, to be positioned at plane X and Y at the radius of 0.5 meter and 0.25 meter, respectively, together with their respective angle theta X and also theta Y. So what does this mean now? First, you calculate as usual. When you calculate as usual, you have so many impeller, so only focus on the impeller that been modified. So you only have these 3 impeller in your table, am I correct? Plus 1. Plus 1. This one you have H, D, and B plus X and Y. Because this one, the first part will be talking about forces. The second part, this one they are talking about what? Adjustment. And you're very fortunate that you have only one dynamic force. If this one counted, this one talking about the total force, you need to do all the 8 impeller by statics analysis, but please be ensured that all the impeller must be after modification. The modification impeller is only HDB. The rest is basically as the initial mass of the impeller. Okay. Okay, now you do this one in table plus this one. So the other one will be the counter mass is basically the mass you have to put on the system. Now you take the same impeller, the whole impeller, A, B, C, D, but you remember only H, B, D is only been defected. This one is been defected. The other one is what? B and D. This one is defected. Plus X and Y. So this one you will have MX. This one will have MY. Okay, to be positioned, what does it mean? Is plus here and plus here. If this one is said that the counter mass should be taken away, so this one become negative. Is that clear? So you have to read the equation very, very careful. Okay, this one I think you can do this one on your own. The next one, this one also not very difficult. Look at here, only 3 cylinder. This one we done earlier. So this one also same thing as what we did earlier. This one you can do on your own class by referring back whatever you have in the first set of the test just now. This one, because most of students asking about this one. I don't know why. I think this one is not very difficult. Look at here. Excuse me. So you have show the variation of torque. This one, the variation of torques for an engine. So this one what? This one from the engine or for the resistance? The graph given. Engine what? Is the engine. Is coming from the engine. Why? Because the engine is varies. The engine varies. The torque engine is varies. All varies. Why varies is a torque engine. Why varies? Because you keep engaging gear number 1, 2, 3, and so forth. Then you back to gear number 1, and you know that gear number 1 gives the higher torque compared to the higher gear. When we what happened to the friction? The friction is always constant, coming from the capacity of the engine, and also the level of the road, and also the friction from coming from the vehicle. So that one all constant that you cannot control. Okay, look at here. They provide you all parameter complete, isn't it? Isn't it? Then you need to calculate the mean. Sorry, you need to calculate the T-mean, obviously. And this one, yeah. Mean speed. Mean speed is not very difficult. How to calculate the mean speed? How to calculate the mean speed? It's not very difficult, this one. The mean speed is basically this n mean is equal to n2 plus n1 divided by 2 given here, and the answer is 500 equal to 500 pm. Calculate the coefficient of alpha here. Alpha coming from beta E is equal to I alpha omega mean square. So alpha you will have here beta E. This one is I omega mean square. I. What is I? What is I? We do not know I. Doesn't matter. Is it? Or can also be written. Remember, this alpha can also be defined by what? By n maximum minus by n minimum divided by n. So you can't. This one you cannot use because you do not know what will be the I. Use this one. Okay. So this one alpha calculated. This one calculated. This one the mean torque. This one you cannot run away to do the energy analysis. So how is it? Let me make it bigger here. I don't want to hold you, longer. Yeah, I'm going to stop at exactly 11:30. Yeah? So you need to know what the T-mean here. And of course, before doing that, you need to know whether the given graph is coming from or representing one cycle or not one cycle. So let us now figure it out whether it's one cycle or more than one cycle. You start by -10, constant, shoot up at 55, constant, shoot down up -t. Then it will be slanting here, gradually increase, and then shoot down. It will start all over again. So it will finish up where? This one, isn't it? A or B? A or B? A. See, so this one be your one cycle. One cycle. So we can ignore this one. We can ignore the second part of the cycle. So you need to know what be the T-mean. Find out where the T-mean. So this one will be your T-mean. Why you need T-mean? Because this one all given. So this one is your T-mean. Okay. So how to get T-mean? It's not very difficult, isn't it? It's not very, very difficult. Okay, now how to get to T-mean? How to find T-mean? To find T-mean, to calculate T-mean, or to find T-mean. To calculate T-mean, to find T-mean. How is it? By using what? T theta by the engine is equal to T theta by the resistance. Correct? By the engine is basically coming from all the graph from the given graph. This one. So put it here. Okay, this one will be shaded area of the red one. Shaded area red one equal to what about the resistance? You know that resistance is constant, right? So the resistance will be here. So this will be the resistance. And put it here another color. So you have this one is blue in color. So blue in color, you have this one. This one be your area. So this one put it here blue in color. Yep. Blue in color. Put it here blue in color. Okay, now start calculating the engine. So how is the engine? Calculate the engine graph. How is it? It's not very difficult, is it? Could anyone tell me how? I'm going to another one, but very unfortunate that we don't have enough time. The one that I'm going to show a bit. If you can stay a bit longer after I complete this one, I give you another example. Just to share with you the idea, because the other one is very rare in the exam or in the equation. Okay, you have this one. So you will have the graph. Here is this small portion here plus this one. This one is not very difficult. This one is the mean. Put it here, yeah. So the engine, basically for engine, you have the engine is this one below negative. Okay, negative. Negative. This one is 3 by omega. Go back here, 3 by omega. This one, yeah. Negative. Oh, sorry, 2 by omega. I'm sorry, yeah. Negative. This one. Hold on a bit. Where I'm focusing, this one is not correct. This one. Yeah, this one, huh? This one, this area, then this area, then this area, plus the last one, this is the area. Okay, that is the area that we're going to look for. Huh? Okay, so you can do this one on your own class. I think this one is same as what we did earlier. The other one I want to share with you is here. This one. Let me give you another last topic. This one, as one of your friend asking about this one. This one, yeah. This is the 19. Oops, sorry. The other one is where are you? Oh yeah. Okay, now 1819. This one, isn't it? One of you just now asking about what if the crank is not at the top, but in fact it will be vertically, but at the bottom. So when you have this one, for example, don't worry, it's exactly the same here. So this one become your reference. This one become your reference. So your equation or your graph will be here. And what about your V? V will be measured from. It's not measured from this one, yeah. This one is your connecting what is measured from the line of stroke to line of stroke. So you have this one position divided by 2. So you have this one 60 degrees, another one 60 degrees. So how do you solve this one? It's not very difficult. If I can share with you a bit. If I can share the one, how are you going to solve this one? Anyone? Before we end our meeting tonight, yeah? So anyone would like to share? Anyone? No? How is it? Okay, now start with this one. Okay, this one is your crank, and this one is your angle with 60 degrees, another one 60 degrees. So if we start with a primary direct crank, for example, where theta is equal to 60 degrees. The crank is here, isn't it? Okay, now, so how is it? So your cylinder number 1 will be, where is cylinder number 1? Go back to the equation. Number 1 and 2 as what we have. This one is number 1 and 2. Okay, so how does this number 1 and 2 now? Remember I did mention about primary direct crank is always not. It's always not. It's always not. One. It's not one. It's always not balanced. So it will fall here, isn't it? It will fall 1 and 2. Okay. Then move on to this one is primary reverse crank. This one theta equal to negative 60. You're working here. Crank is here. This one is what is the rotation just now? Is this counterclockwise? This one is counterclockwise. This one will be clockwise. Omega here and omega here. So how is it? So this is your working. Your working is here. This one, and this cylinder number 1, cylinder number 2. Crank will be here. So how is it? This one is of course 60 degrees. Remember what is the keyword? Measure from where? Measure from keywords. This is the keyword, remember? Measure from line of stroke. To where? To common crank. To common crank. Okay. So how is it? Measure from the line of stroke. This one, isn't it? two common crank. Where your common crank following the given direction. This is the given direction. So here it will move that one. What be the angle? This one is 60. This one is 120. Is it? Yes or no?
Yeah.
Yes or no? But reverse. Correct? But reverse. So you will move the other direction. One will be here with 60 degrees. Yes or no? Okay, now number two. Number two, what happened to number two now? Measured from the line of stroke. Just remember that the keyword. Measured from the line of two common crank. How far it go? It goes on 120. This one another 120 is 240. So now you also go 240, but what? Opposite direction. So this one is 120, another 120, 240. So cylinder number. Balance, not balance, it's not balance. So what will be the result? What will be the equation used? The equation used is F. Remember, this is the primary reverse is equal to N. This one is the M omega square arm divided by 2. You have cos theta here. So what will be your cos theta here? So this cos theta, remember, yeah, this cos theta, this cos theta is nothing to do with this one. It's nothing to do with that. This cos theta is belong to whatever you have this one. Okay, this one is correct. So how is it? Cos theta. So this one is 60 degrees. So this one will be cos what? Cos what? Cos 60 degrees. Isn't it? To ensure that that one will fall vertically. The rest you can do on your own. This one is only for this because I already exact 11, half past 11. Huh? So any other question before we end our class tonight? This one is also not exactly. Yes.
About
Okay.
this question.
About what?
This question.
Okay.
Ditanya dekat maximum primary and secondary force.
Okay.
What is the meaning of maximum?
Maximum primary and maximum secondary force. Okay, go back to here. What is the meaning of maximum and minimum? Okay, now F is basically what? Primary is basically F, this one, yeah, is the primary direct plus S, this one is primary reverse. You add up together, it give you maximum. Same thing F for secondary is also part of it is a secondary direct plus F secondary reverse. Okay, so that is the maximum. This one, this maximum. When you add up together, become maximum. If this one, no, this is not maximum yet because only part of it you calculate. You get what I mean? So there must be two components which give you primary direct and primary will give you the maximum. Okay?
Thank you.
Any other question before we, close our session? Yeah, this one. Try to also use or familiar with this one. It is not always been given in what figure. Sometimes the figure will be elaborate in terms of sentences. So please be very careful with this one. Sometimes you need to read the equation and you have to construct your own graph. Okay, I think that's about it. Really hope that you enjoy my lecture and also benefit to you, for the revision purposes for the test 2. And I would like to wish you all the best in the test 2 for everyone those attend the class, and also not only in my section, the other section. I wish all the best and pray to God, inshallah, you get good mark in your test 2. That will be, inject you some spirit for the exam. Okay, with that, I end my session. Class, thank you for being with me. Thank you for respond question. So with that, I end my session with Assalamualaikum warahmatullahi wabarakatuh. Stay healthy and stay safe, and good night to everyone. Thank you, class.